Hey pumpkins, I hope you're having a safe digital learning day. So what we're going to do today is called the multiplication rule. Okay, and this is going to be our introduction to statistics. And I heard that statistics is going to be fine, I promise you. I have not lost anyone in this section that I know of. Okay, so let's look at this problem. Dana has a box with 7 marbles and 3 pink ones. Okay, 2 marbles are drawn without replacement. This is going to be important from the box. What is the probability that both marbles are blue? Okay, so before we even get started, the question needs to be how many total marbles do we have? Okay, so you always add them up. And so we have a total of 10 marbles. Now, it's asking both are blue, so they're asking this, blue and blue. Okay, it's going to be important. The word and means multiply. Okay, now if you're thinking you've done something earlier where you add it, you would be correct, but this is not in this section. Do not add. Now, so let's handle the first. I pull a marble out. Now, here's the best part about statistics. We are going to believe we're so good that we actually pulled a blue marble out. Okay, so there are 7 blue marbles out of 10 I have a chance of getting out, right? And I'm going to assume I got a blue because we're that good. And no, I did not cheat. Okay, now here's the important part. Without replacement, you're still holding, I know it's not blue, but we'll pretend this is blue, marble. And then I'm going to go in with my other hand and get another marble. So how many marbles are left if one of them is in my hand? Anybody? Okay, good. I think I heard someone say 9. So now again, this is the best part. We're going to assume we're good enough to get a second blue. But remember, I'm holding a blue marble in my hand. So how many blue marbles are left? That's right, 6. Now, yes, I'm having a moment. Okay, so you're going to multiply across. So 7 times 6 is 42. And then 10 times 9 is 90. Now we do have to reduce our fractions. Now it's so much easier if we do have a graphing calculator to say math enter. Let's see, I know this one is divisible by, oops. I kind of sort of ran out of room, didn't I? So this is 21. If I take a 2 out, and whatever I do to the top, I do need to do to the bottom, and I get 45. And that is my answer. Okay. Now I want to take the same problem. I still want my blue. Let's see if I draw a line. Can I draw a nice line? Nice-ish. So let's take a blue. Okay, this is going slow. And another blue. So we're doing the exact same thing. Oh, darn. I have to go slow when I write with this pad. Okay, with replacement. Okay. Okay, so here we go. We're going to put all our marbles back. So we're starting back still with a total of 10 marbles. Whoops, that did not want to go down. So we still have a total of 10. Okay. So remember, all the marbles are back in the bag. So what's the probability of you choosing a blue? Okay, yes, just like before, it's 7 out of 10. Now, you do get to assume, again, we're good, that we have a blue marble in our hand. Oopsies. That should be a multiplication. This is why I should not talk and write. I get my blue marble and I put it back in the bag. What's the probability of me getting another blue? So how many marbles are in the bag? That's right. We have all 10 marbles. Okay, and how many blue ones are in? And the answer is 7. Okay, so again, we multiply across the top and multiply across the bottom. And this is how we get 49 out of 100. 2 different answers. And it's all about wording. This one was with replacement. The one is without. So when you read, you're going to have to really make sure you read those words. I know I'm asking a lot for you to read. In math, it's crazy. Okay, so here we go. Our second question. John is going to draw 2 cards from a standard deck. What is the probability the first card is a queen and the second card is a jack? Okay, it did not specify. Well, he's drawing 2 cards. It is implied without. It's kind of like if we were playing Uno. It's not like you're going to hand me a card, put it back, and hand me a second card. Even though I would like that. Okay. Ooh, I can't spell. Ooh. Okay, because he's drawing 2 cards. Okay. If you ever have a question, feel free and send me a remind, and I will answer that question if you are unsure. Okay, so the first card is a queen. Notice the word and, so and means to multiply. And the second card's a jack. Now, some of you may not be familiar with cards, so I have another slide right behind this one. So things you should know, there are 52 cards total here. No, we do not play with jacks. That's considered for weird games, if you want to think of that. And then there's 13 suits, okay? Okay, the first one here is called a spade. Oh gosh, gee willikers. It's been a moment since I played a game, haven't I? Ooh, darn. Okay, so let's race. Let's try this all over again. I know Mr. Toronto's not perfect, and you're laughing at yourselves. Oh well. So the first suit here is, ooh, that is definitely too big for us. Okay, is a club. Second one is a spade. Those are the ones people do get confused. And then we have a heart, just like your teacher does. And diamonds. They are a girl's best friend. Okay. Now, 2 of them are red. 2 of them are black. I did that in order. These are your face cards. Jack, Queen, and King. And not to make you feel bad, Jacks are Jays, Queens, and Kings. Aces are not considered face cards. Okay? If you have any questions, feel free and let me know. So, probability of pulling a queen. So notice I have 4 queens out of how many total cards? Good job, 52. Okay, let me go back. So for a queen, there's 4 cards out of 52 to get a queen. And then the next one is a jack. Now, you are going to assume you get yourself a queen. So how many cards are left? Remember, I just picked 1. Good job. It is 51. So then, how many cards are jacks? And notice there are 4 jacks. Oops, I went the wrong way. So there are 4 jacks. Okay, so multiply across the top, and that is 16. Let me get my small little calculator and multiply the bottom 2. Ooh, that's a not cute number. 2652. Let's see, is this divisible by 4? Oh, yeah. So I divided each by a 4. So I get 4 over 663. Again, yes, I would like you to reduce. You can even do it. You know, I believe in you, my little ones. Okay, last but not least, Emily has a folder of colored paper. The folder has 4 yellow colors. paper, 5 black colored papers, 6 white colored papers, 5 brown papers. She picks one paper, records a color, and puts it back. Big, big important. And draws another. What's the probability of her taking out a brown? So we want a brown. Right? And a yellow. Okay, so first off, we need to get our total. Okay, so 4 plus 5 is 9, plus 6 is 15, plus another 5. So we have a total of 20. Okay, so first she's picking brown. How many brown papers do we have? Good job. We have 5 out of 20. Okay, now remember she puts it back. So how many papers do I still have? Correct. Good job. You're catching on. Is 20. Okay. Now she's pulling a yellow. How many yellow sheets? 4. Okay, so this is going to be 20 over 400. And if I reduce this, I believe, hopefully I'm right, I get 1 out of 20. I hope this makes sense. Good luck on your ventures. Bye, guys.